Oh,
She's good to go?
she's good to go?
Okay.
All right, then welcome everybody to panelists and attendees alike to the town hall meeting where we will do a presentation on a new project being taken on by Public Works and a wastewater treatment facility for a bio dryer. And I'll turn this over to our Public Works Director, Cody Colt, who will then introduce the team who will do the presentation. Upon the presentation's completion, Council, please consider yourself in listening mode, and we'll ask citizens to address the entire council on this matter before them tonight. They are the council tonight. So, Cody.
Awesome. Thank you, Mayor, very much. And sorry about the scheduling. When I scheduled this town hall 2 months ago, there was one thing on the agenda. And as you know, more and more stuff gets added to the agenda. So the agenda got longer and longer. So to be kind of brief in my introduction, I'm just going to kind of walk you through how we got to this point. And then I'll pass it off to parametrics, and Doug and Brian will be able to kind of walk you through the process and everything that's happening. So I'm going to share my screen. You should see a little PowerPoint that says BioDryer Town Hall. So really quick, I'll just go over how we got here and then kind of just a brief explanation of why we're doing what we're doing and kind of how council has led to this decision to proceed with the BioDryer. And then I'll pass it off to parametrics. So in 2016, as you know, council adopted the sewer facilities plan. That gave us kind of a path forward with our sewer facilities and WRF. In that plan, there were 3 phases. Phase 3 specifically addressed a biodryer. Phase 2 talked about the new WRF, which is the MBR facility that council approved in early 2020. The biodryer was originally slated for 2024. With the help of parametrics, our project manager and the sewer department, we realized that it would make sense financially and feasibly to have that biodryer be engineered and designed to be built at the same time as a WRF. Public Works Committee, in their infinite wisdom, decided to move forward with that and recommend it to council. And then council adopted that engineering plan with parametrics to engineer a biodryer in conjunction with a WRF in the summer of 2020. And in keeping with our tradition about Yelm being open and transparent as possible, and with Public Works Committee, along with council and the mayor, we decided to host a town hall. This is that town hall to kind of let public participate in the process and get as much input as needed. Obviously, there is a public hearing notice that was put in the newspaper a couple of weeks ago about this town hall, and there will be another option for public to participate when we have fully developed plans, which will be coming later this summer. And public will have another chance to give feedback on those fully developed 100% plans. So that's how we got to this point. And just a really quick rundown again of the finances of this, because I know it'll be a question. These numbers were taken at the beginning of the year. Our solids expenditures in 2020 were $550,000. That was removing of sludge from our plant, shipping it to Shelton, and then the other was doing our septage pumping and step tank maintenance. So biodryer cost, that is how much it costs to run a biodryer. That was the estimated cost we were originally given. It's actually a little lower than that to run the biodryer. Was around $245,000 a year. So you have a net savings of $305,000. Obviously, some of that net savings will go to pay back the building of the biodryer, but you're looking at a 5 to 6 year turnaround return on investment on a biodryer and a septic receiving station facility. I'm going to stop there and pass it over to parametrics. And then we'll have obviously a question and answer time at the end, where if there's questions about any of the things I just talked about, we'll be able to address those there. So I will pass it over. I believe Doug will be taking it from here.
Thank you, Cody. Let me share my screen here. Okay, and I want to, everybody see that? Okay. Let me start at the beginning here. So I want to, even though we're talking about the biodryer, I'm kind of taking a step back and talking about biosolids in general, because really that's what we're talking about. It's not just the biodryer. You're taking a totally different direction with the solids that you produce within the city and at the water reclamation facility. So we're going to kind of give an overview of that process. And then we actually have the manufacturers here, representatives, to talk about the centrifuge, which is I'll get into in a moment, and of course the biodryer. First off, in Yelm, with all the step tanks, solids are removed in the step tanks. Currently, they're pumped out and trucked to another facility. In the future, with these changes, Yelm will be able to process these solids. So instead of spending money to have somebody else do it, you're going to be able to do it yourself and have a beneficial product come out of it. So at the water reclamation facility, the liquid waste come in from the step tanks from all over town, businesses, homes. And we have biological treatment. Now, I'm not going to get into detail about biological treatment, but just to say, the liquid waste coming in, that's like food for bacteria. And when you combine bacteria and all the food, now you get more bacteria. And the population of bacteria grows. And you have to maintain a certain level of bacteria. Otherwise, it doesn't settle well. It doesn't, the process doesn't work. So the bacteria is wasted. You basically get rid of bacteria. And these solids are then dewatered. Some of the water is taken out and trucked to another facility. And again, in the future, Yelm will take care of these solids. So if we look at the future, now we have the step tank solids. That's not going to happen right away. And there will either come in directly and be put into the biological treatment or go directly into the solids treatment process. You also have the liquid waste coming in. Again, the bacteria, that's really the solids that are generated within the process. We first go to a centrifuge. The centrifuge, just like the name implies, is rotating and basically spins off all or a majority of the water. It takes it up to about 20% solids. Okay, still a lot of water in it. But from there, it goes to the biodryer. And I'm not going to go into detail about the biodryer because we have the manufacturer here, and I believe they're going to have a video to really show the process. But it'll take it up to 90% solids. And what you get out of it is not just biosolids, but it's called Class A exceptional quality biosolids. And why do we want to be exceptional quality? Because then it's available for public use. Looking at the law, the Washington Administrative Code, we see that exceptional quality biosolids has to meet certain limits. It says table 3 of WAC 173, 308, 160, and pathogen reductions of another one, and vector attraction. Okay, so these are all the requirements that the city is going to have to meet exceptional quality biosolids. I know there were some questions about this that the city got, so I actually put in, these are the concentration limits from table 3 that was in that reference. You can see different metals that are in limits for various ones that the city will be testing for. Initially, fairly monthly, semi-monthly test. Once they get a baseline, then can be expanded out to quarterly. And the testing regime is really based on size of facility. The other requirements will meet what's called a time and temperature. It has to be in the vessel and meet a certain time and temperature for it to meet the requirement. And the final one, just like I was showing earlier, it will be greater than 90% solids. Okay. These are the requirements that the state has put forth that the city will need to meet. And they have a testing plan that will ensure that they meet these requirements. With that, I'm going to stop sharing and turn it over to Chris, who is going to take it next? Talk about the centrifuge.
That would be Jared Swanson with Centresis, and we'll be able to
Okay.
talk about the technology and go through that.
Okay. Jared, do you have the floor?
All right, thanks, Doug. Yeah, with the centrifuge, there's not a whole lot to discuss. I think the main focus is on the biodryer here, as Doug kind of explained. All the centrifuge is basically just a clarifier that separates solids and liquids at a high speed and at high G-force. So that's all we're doing, is we're just kind of preparing it for the biodryer, so the biodryer can do what it does and take it to the Class A step. So unless there's any specific questions about the centrifuge or how that works, I think I'll let Valentino and his team talk about the biodryer.
Okay. So the next step after the centrifuge, the dewatering step, would be going to the biodryer. Valentino with Bioforce Tech is going to talk a little bit about his company and the technology.
Absolutely. Hello, Council. Hi, Mayor Foster. Thanks so much for having us today. It's a pleasure. So let me, can I share my screen? Just, I would like to pull up some slides here just for you to understand a little bit better about our company. Let me see. Do you confirm you see my screen?
Yes.
Beautiful, beautiful. So before we start talking about the technology, I would like to spend a couple of minutes just to talk about the company and the people who make the company here. So our company name is Biochar Corporation. We are 100% American incorporated, although we come from Italy. We've been here for about 10 years here in the US dealing with biosolids, and we have around 35 commercial facilities all over the world, mainly focused in Europe because that is where we come from. As a mission statement of our company, which is always very important for us to say that out loud, again, for you to understand more who we are. So our mission is to protect human nature and to deliver sustainable technologies that deliver a zero waste future. So we have four main core values within our group, which the first one is to deliver an affordable waste management system, to have valuable products from processing organics and biosolids, to protect nature and human health, and to have a self-sustained and green process. So talking about the company, we come from a larger European group of companies. The first one was founded in the 50s after pretty much World War II in northern Italy. The main business is to produce and to manufacture turbines for energy generation. In the 90s, the Protection Extrusion Group was being founded, now leading the worldwide markets, supplying aluminum extrusion presses, literally with hundreds of installations all throughout the world. In 2012, we bootstrapped Biochar Corporation, which again is 100% United States based. We have the operating headquarters in South San Francisco, where I'm actually located right now. In 2016, we partnered with the Pyreg, which is a German company that together we developed the second part of the process other than the biodryer, which I'm going to talk a little bit about it because it's a possibility for the city of Yelm if they want to go above the Class A status and produce something even more sustainable, which is called the biochar. And so we have a partnership with Pyreg where we do joint development, joint manufacturing, and we are in charge of the United States market and they take care of the European market. In 2020, we announced a very important partnership throughout our group. So we have Waste Management now being a minor shareholder in our business, and Waste Management is the biggest United States-based company, waste service company with around 40,000 employees, and it's a multi-billion-dollar company rated in the Fortune 500. So again, they're a minor shareholder in our business. They're supporting our company and sharing the same long-term vision to sustainably managing organics and the biosolids, of course. Looking at the system, I know today we're focused around the biodrying, which is a great technology that is needed to remove the water from biosolids, where from the centrifuges, as we just said, we get biosolids with roughly 80% water content. So it is very important in order for us to extract any value from the product to dry that efficiently before. So we developed the biodrying concept, which compared to any other dryer available on the market, it can save up to 60% of the energy demand because of the way that it operates, because of the way that it's been engineered. So instead of burning natural gas or consuming electricity like any other dryer would do, just to remove water from the biosolids, our drying system works symbiotically with nature. So Doug connected to the biological part, to the bacterial activity, how important that is in a wastewater treatment facility and in any biological process. Well, we do utilize the same principle. So it's like a composting process that instead of leading to a compost product and taking 30, 60 days, with a lot of human labor involved during the composting procedure, our machinery, it is fully automated, and in just about 2 days, it is able to receive 8 wet tons of biosolids at the 20% water content and remove most of it until we get to a 90% dry product that, as Doug said, will get the status of Class A or exceptional quality with way less pathogens in it. It's a much safer product to be used in land or to any other distributional aspect. And in any case, we always have the possibility in a later future to connect with the second step of the process, which is a pyrolysis system that at that point will be able to process the dried biosolids after the biodrying step and producing a carbon product, which is called biochar. Biochar is an amazing product that we've been developing for the past 8 years here in the US. We have found a very nice placement to the market here in the States and as well as in Europe. And it's completely safe and free of any pathogen, any contaminant, any concerning emerging contaminants. So it's a very much safe product, as Class A can be. So the biodryer is very much scalable as well. So very important aspect for the city of Yelm is not only to take care of today's problems and biosolids production. We just heard about how new developments may, arise for the city with an increase of population and tourism, whatever that will be. We do expect some growth within the biosolids production because, of course, more people equal to more biosolids produced. And so if the city of Yelm installs a single biodrying unit, then we will just simply leave room to install more units, more modules following the expansion of the city, the projection growth in terms of population. So it's a very easy concept, very easy machine to implement, to install, and also to scale. We do all of the pre-manufacturing between our manufacturing companies and the system is delivered as a pre-built, fully engineered kit. So when the city of Yelm grows, another biodrying unit can be plugged in without changing anything in the previous design, optimizing cost, reducing timing, and making sure that the city of Yelm will have enough capacity to accommodate biosolids growth. Looking at the technology itself, again, it's a biological process. So instead of merely focusing on burning natural gas or just consuming electricity for the sake of drying, we utilize for most of the drying process bacteria that are already within the biosolids. So we do not do any further injection. We just simply take the water, the centrifuged biosolids will be introduced into the biodrying system. And again, after 2 days of processing for the single batch, we will get to a Class A compliant product with 90% solids content instead of having 20% solids content. So the benefits are multiples. Of course, we're reducing the volume, sustainably saving 60% of the energy demand that any other dryer otherwise would require. Of course, saving taxpayer money on the electrical and natural gas bill. But also, if you think about it, if you don't have a drying system, a bio-drying system, even if you centrifuge the biosolids, then you will be trucking sludge with 80% water content in it, which you're paying to get rid of water, which is silly to say, but that is the reality of the things. If you install a biodryer, not only you will be hauling much drier solids with much less volume, but also you will not be having a Class B product with pathogens with way more restrictions to be then disposed of or applied to the land, because the biodryer will be able to reduce the pathogens to meet the EPA 503, which is the standard federal law by which we will respect the Class A compliance by reducing the pathogens below the threshold. The metal concentration will be respected because the city of Yelm biosolids composition will be very much suitable. And also we will be meeting the vector reduction requirement by, again, producing a 90% solids product with way less possibilities for vectors to then spread the pathogens and germs. That is the purpose of being a Class A product. I have this video that hopefully will help you visualizing how the process works. And I don't want to take too much of your time, but I know it's a big focus of today's meeting. So I apologize for taking longer than maybe expected. So again, it's a batch system. So the city of Yelm will be loading the system every 2.5 days, pretty much with up to 8 wet tons of biosolids at 20% solids per batch. And the system will automatically start the process. So everything, again, will be fully automated. We have an artificial intelligence controlling system built in that every 5 milliseconds keep checking on every sensor, every side of the process to make sure that the energy demand, the throughput of the system is always optimized to the most we can. And you can see here, the system will start to inject air from the outside, room temperature, room ambient air with no external energy being introduced into the vessel. And this will allow bacteria within the biosolids to start generating heat. Think about composting. You have a biomass there sitting, air naturally flows throughout the particle size. Well, bacteria will start generating heat. So from room temperature, the system will reach 150, 160 degrees Fahrenheit at the most. And at that higher temperature, of course, water will start to be removed. So the second blower, the second piping will start to remove all of the moisture, all of the water. And this 150 degrees Fahrenheit is then remain constant for the next 24 hours. So we have about 30 hours for which the biodryer is drying sludge with no external energy, because again, bacteria are doing all of the work for us. When we reach about 55, 60% moisture content, biology doesn't help us anymore, because the lack of water in terms of the environment for bacteria doesn't allow them to keep generating that amount of heat. And so the third phase of the process is when we do need to use some external energy source. So in that case, we will have a process water heater, like a regular water heater, that will supply some hot water to the biodrying system, and through a heat exchanger, we'll simply heat up the air and finalize the drying cycle as the required 90% solids concentration. So once the batch is done, again, the system automatically will be rotating, positioning the opening gates or the feeding gates to the receiving conveyor, and the dried Class A biosolids would then be discharged to whatever receiving bin or dumpster area to then be applied to land, or whatever distribution channel the city of Yelm would decide to go with. So very simple concept. Again, we do focus on biology. We do work symbiotically with nature in everything we do. It's a very much a clean system. We've been fully permitted here in California. We have, again, 35 commercial facilities running worldwide between Europe and the United States. The first installation we were able to deploy here in North America is in Silicon Valley at a very, I would say famous wastewater treatment plant here in the area, because they are very innovative. They're very sustainable, as all the area within us. And so after that, we of course deployed biodryers and pyrolysis processes there, and we are generating biochar from their biosolids. So for the city of Yelm, again, this will be the first required step to fully move towards sustainability by even exceeding the Class A status and producing a completely different product that will be the biochar, of course, in a later future. So that was the end of the presentation around the biodrying system. I will leave the screen to you. Let me see how I can do that. And here we go. So if there's any question or anything further that Chris or Doug or Cody would like me to expand, just please let me know. Otherwise, I'm open for questions.
That was great, Valentino. Thank you.
My pleasure. Thank you for having me.
Cody, that pretty much ends our presentation. Turn it back over to you.
Okay, awesome. Thank you. So thank you, Chris, Michaela, Valentino, and Doug, Parametrics and Bioforce Tech. We're going to open it up to questions. I know there's a couple questions I had sent. Doug, did you get those questions, Chris, Doug?
Yes.
So can you answer, do you want me to read the question and then you answer it, or do you want to read the question and answer it if you can for the couple we got sent?
Well, I think I could probably summarize. I think we've answered a couple of these already.
Yes, for sure.
But the first question had to do with microplastics. and I want to be careful how I answer this, mainly because it is something of concern. There's something, it's something that there is more research on. But at the same time, I have no idea what amount could be in Yelm's solids. It's many times it's a function of, what's going on in the system. How many people have synthetic clothes that they're washing? I mean, there's a lot of different factors that impact microplastics. Currently, it is not something that is regulated. I guess in many ways, the question should maybe be redirected to the Department of Ecology on, is it something that's on their radar? Because as regulators, there would be the ones that would put limitations or require testing for such items. So, a tough question, because really I don't have a lot of information, because we just don't test for those type of things because of the current regulations. The next question had to do with talking about the vendor and the technology. Hopefully Valentino represented his company and the BioDryer technology. So I think we've answered that one. And I think the final written question talked about the standards for Class A biosolids. That's why I added those slides that talked about the regulations and what we have to do to meet the Class A exceptional quality biosolids. So hopefully, Coda, we have answered those three questions. Again, the first one's it's a tough one, but I think we'll have to stand pat with what I've said. So.
Sure. And there are questions coming in. We only have one so far. Can you guys see the questions coming in?
Yes.
Okay.
Is PFAS, PFOS being analyzed? No, again, and they're not regulated. Doesn't mean that's not a concern, but they're currently not regulated.
Can I maybe add something to it?
Sure, Valentino.
I would like to expand on that. So first, we take it very seriously, our commitment to the environment, as I begin my presentation with. So on the PFAS issue and also on the microplastic issue, we are very sensitive on those two topics. It is completely true, whatever Doug just said, they are not regulated compounds yet. So there shouldn't be any, immediate concern within the city of Yelm Biosolids. We don't know how much microplastics or PFAS and PFOA will be present in the Yelm sludge. But here again at the company, we initiated testing back in 2019 on PFAS and PFOA. So before even anybody was aware of this issue, before documentaries were out on Netflix and so on. So we do have a solution in-house. So to be frank and very much open with all of you, PFAS and PFOA are definitely going to be everywhere, like from the water that you drink, your tap water to, they found PFAS in milk in Michigan. So, I mean, they are everywhere. The, companies who developed them in the 30s, unfortunately, they had the go-ahead to keep producing them. So they are literally in every part of the planet, from Asia to North America. And the biodrying system will not be able to remove those from biosolids, as will not be ideally able to remove most of the microplastics, simply because of the low temperature as it operates. No any other drying system available on the market today will be able to do so. It's impossible, because they're called forever chemicals. They have a very strong bond as a chemical bond with the carbon. And so you do need very high temperatures or thermal processes to destroy those within the biosolids. So as I said during my presentation, the first step for the city of Yelm to fully turn into a sustainable biosolids management would be to install the biodrying system. So the biodryer, no matter what, it will be needed to, again, remove the water, to then get to a second step eventually, if again microplastics and PFAS become a regulated compounds. And then at that point, we can then plug in the pyrolysis process, which we do pyrolysis at 1100 degrees Fahrenheit. And second step is done at 1900 degrees Fahrenheit. So we do have high temperatures throughout the second step of the process. And during the testing that we've done in 2019, and then in 2020, we had the opportunity to work directly with the United States EPA. We've done joint testing with the federal government that regulates or is, at least studying those compounds at our commercial facility in the Silicon Valley. So we have shown destruction of PFAS and PFOA within the biochar product that we were able to produce throughout the second step of the process. And so the answer to your question, it is yes, we can then destroy PFAS and PFOA, adding the pyrolysis process to the biodrying system. So again, biodryers will be needed as the immediate need for the city of Yelm to first save money, second to get to a better product, Class A biosolids, and then as a longer value proposition, we can then plug in the pyrolysis process to fully destroy microplastics, PFAS, PFOA. Pretty much the end product will be completely free of any compounds, chemical, or any emerging contaminant. So just a general assessment. We are very much aware of the problem and we are taking it very personally. So just as an FYI to all of the council meeting here and the citizens that are listening.
So thank you, Valentino.
Thank you, Valentino. I'm going to jump in here as moderator of the town hall and suggest that people do type in their questions into the Q&A format, and then we'll answer those live as they come up, and Doug and Cody and team can monitor that. And then I'll click on them when they're done. And if you're unfamiliar with that, then we can get back to either raising your hand or in some other way getting my attention.
For sure.
So we'll go on now to Rennie Storms, the next question in the queue.
This one will be for me. I think it's a funding question. So what are your backup plans in case the biodryer malfunctions? The good news is we will still always be able to, if we have to in emergency, we can pump and haul the undried solids to Shelton, Tacoma, another facility. So that's always an option if the biodryer malfunctions. The funds that were shown in the first slide, the 550,000 is how much the city currently spends on hauling and septage disposal. So those funds would go directly towards supporting the biodryer, cost of, gas, electricity, along with maintenance and the lease of the biodryer itself, or the cost of the biodryer to buy it. And all our funding, the good news about the biodryer and that the solids part of this project is it's all funded through the city. The city has the means to fund this through the sewer fund and the sewer capital fund. So for the biodryer itself, there are no federal funding. There's no grants from the state that we are trying for those, but we have the capability of funding ourselves within the city. And can we sell fertilizer at other locations besides Yelm? The plan is we will branch out on those kind of options later on. Initially, the solids will be used, or the biosolids will be used in Yelm as fertilizer for our local city parks. We are in talks with the school district and a couple other places to possibly supply them with biosolids, and then have a public available option once we reach that high quality limit or the high quality threshold. So the public will be able to use those for their own lawns and whatnot at a certain time, and we'll have that picked out. The next question is probably a question for Doug or Valentino. There's still low amounts of pathogens within Class A biosolids. Does this mean that using these types of biosolids as fertilizer is better for grass shrubs rather than vegetables, fruits in terms of safety?
I would say that it would be safe for vegetables. Again, this is exceptional quality, not just Class A. It means it's for public use. I've used similar products in my garden, and I do it without hesitation. There's a website out there, Northwest Biosolids Association. They talk about the different uses of biosolids and the safety of biosolids. We recommend to the attendees of maybe looking up their website, and they also have a number of connections to other sites that talk about the safety of using this type of product.
Just to piggyback on what Doug said, is the city has created, with the help of our communications director, a BioDryer page on ours, which has a link to that website that Doug just mentioned, along with a bunch of other information about BioDryers, FAQs. We will be shooting, that link is on our Facebook page, but we'll also I'll post it probably later today. I'll show it here before we wrap up, and we'll send it out again as another link so you guys can see it on our city webpage. I lost my question sheet.
So the next question is about, does the pyrolysis process remove the microplastics as well?
I'll take this one. The answer is yes. It removes them 100% for what we've been able to test. So yes.
Valentina, that's been verified by third-party testing, including EPA and separate labs, correct?
Yes, so the microplastics, the EPA did not look for those. Specifically, they were more focused on the PFAS and PFOA, aspect, but we have third-party labs certifying that microplastics are also removed, as well as PFAS and PFOA within the pyrolysis process.
I'll combine the next two questions. This question would like to know if the process can extract the metals and phosphorus to sell and have them recycled. And another like question is, will heavy metals be present in the biochar?
I'll take this one. So on the heavy metals, so whatever is in Yelm's biosolids, most of the heavy metals would then be found in the biochar. Some of them would be gone through the pyrolysis process because of temperatures. But what happens in the biochar and heavy metals is that the carbon structure of the biochar, by doing pyrolysis to organics to biosolids, pretty much make bonds with the heavy metals. So the heavy metals are trapped within the carbon structure of the biochar. And we have done plenty of leaching testing and of course, a product analysis on the biochar, and all of the metals simply do not leach. So leachate testing have detected no leachate of heavy metals within the biochar. And so although they are there because they were in the biosolids, they don't go nowhere. So it's a very strong bound. And again, we have third-party testing. We've done plenty. And so shouldn't be any concern. In any case, we do follow and respect the federal regulations. So by the EPA, of course, the ecology regulations. So we always be within the limits and respecting those federal, local, and state requirements for exceptional quality biosolids within the concentration of the heavy metals as well.
The next three questions are very similar. I don't know if you can all read them very well. I will read all three, and I think you could probably craft an answer that would address their concerns, and actually all four. So it goes that the pharmaceuticals, heavy metals that cannot be removed by these processes, why would then the end product be called safe and harmless for foods, gardens, and pastures? You don't feel that's been addressed well. The next question is, would we be doing a major oversight on these things, and will reports be generated and available, and any studies on possible toxic or environmental harming effects of the fertilizer in the process for the next 5 years, will those become available? Again, thousands of chemicals, many unknown, are left in the pellets. Putting them in public places or on our food is not healthy. Food and plants take up some of these contaminants. Rethinking how and where to put them would be wise. And a last question like that is studies to see if the fertilizer effect will harm local aquifers and wells. Can you want to address all of those environmental concerns in one well-crafted answer?
Maybe I'll take a first stab at it. Doug, maybe if you want to finish anything that's left. To digress a little bit, I didn't talk about my history. On top of bringing the teams together and providing a solution for the city with Bioforce and Centresis, I've spent the last 25 years in biosolids management, 18 of that on the customer side. I'm a founding member of the PNCWA Biosolids Committee, which I'm still active. I was 12 years on the executive council for the Northwest Biosolids Management Association and a former president. So for the last 25 years, I've been connected to the academia of all the universities in the Northwest, which does an amazing job of studying the effects of biosolids in the environment and the after effects of that. and they're dedicated with all the top universities to talk about the viability of heavy metals, pathogens, emerging compounds of concerns, class B, class A. And I would push people to use the references that the city's putting together for the NBMA website. There's 30 years of research that's dedicated going over these types of educations, and everything that we're going about is in line with the Department of Ecology guidelines. And that's based on science that's happened for the last 30 to 40 years on long acting studies with the top academias and universities of the Northwest. And so I understand there's concerns on the new technologies. And again, Class A, it does have an inherent risk, but is much less than Class B, which is 95% of all the public agencies currently put biosolids to ground for carbon sequestration.
Thanks, Chris. I think the other thing to consider is a lot of the biosolids that have, some of the heavy metals and other things. Also, they're sewer systems that have heavy industry. A biosolids that comes from sewage sludge that originates in Seattle is not Yelm. Seattle has a much larger industry base, that has those type of things going into their wastewater. So it's a bigger concern. What you're producing is primarily residential wastewater. There is some commercial. Now, does that mean there's no heavy metals? No. I mean, there's heavy metals in a lot of different things, but again, it's regulated, and we have to meet those limits to be able to call it exceptional quality Class A biosolids. Cody?
Yeah, I just reiterate that point. The standards are set right by ecology, and we will follow any standard that is set, and we will make sure that we're well above where we need to be in terms of those limits. So that way we are producing the best product we can produce. The next question was, what does the city plan to do with output of the biochar? So I mentioned this, but I'll just reiterate one more time. The current plan is the city will use it in our green spaces. So our city parks for the grass. We currently buy fertilizer. This would save that cost for the city. We wouldn't have to buy fertilizer. And we are in the testing phase of working with the school district and a couple other entities. And they've given samples of biosolids to try and use on their grass green areas to see if they would be willing to use our product. So we're going to testing phase, and hopefully we'll have several users. And then the last option, another option we would like to do is make it open to the public. If public wants this product, which you find in a lot of cities, once this product is available, public really does want this for their gardens and things like that. We would make it available to the public on a weekly or monthly basis to be determined as we make more and more biosolids. Next question, when you move from biochar into the pyro piece, are the temperatures to the level that a smoke or ash type products will be released into the air? So that's probably a Valentino question.
Yeah, thank you so much. So we do definitely have air emissions. That is why it took us, so long to install the first system here in Silicon Valley, because we do have air emissions, right? So what happens during the pyrolysis process is that, I don't want to be too technical, but pretty much by producing biochar, we are able to extract all of the carbon that was within the original biosolids and lock that in place. So production of biochar allows, of course, to get to, pathogen free, whatever you want to, we just said about the end product, but also has carbon locked in place. So that carbon will never go anywhere, meaning back to the atmosphere, providing with the, climate change, but we'll do the opposite. So by sequestering carbon, by fixing the carbon, we then make sure that for the next thousands of years, that carbon will never go away again. In terms of emissions, we do go at the stack with mainly water and whatever is left in terms of CO2. So whatever carbon was not be able to lock in place in the biochar, would that go at the stack? But mainly would be water compounds. So another thing to mention is that we have a current commercial facilities being fully permitted and operational here in Silicon Valley in the San Francisco Bay Area. And again, we have over 35 commercial facilities worldwide, and we're very much familiar with the air emission limits in every jurisdiction between Europe and the United States. And yet we have to see a more stringent air district than the San Francisco Bay Area. So the fact that we were fully approved here by local authorities, by the US EPA, and mainly by the San Francisco Bay Area Authority, leads to the fact that our technology, it is very clean and very sustainable, and air emissions would just be better than any other technology or any other type of process you can potentially deploy to then, to thermally treat biosolids. So very clean emissions, again, mainly with water and some CO2 left that was not able to lock in place with the Biochar production.
Awesome. And then a question from Linda. It seems simple to answer quickly to get to the biochar phase. Perhaps some of the millions that Yelm is receiving from the stimulus bill could be used for that. Linda, that's great suggestion. And the money that is coming in is being thought about of where that could be spent. It is always an option that council may decide to move in that direction with a biochar. Initially, getting the bio dryer online will be the first goal. Once that is online, then council can decide and Public Works Committee can decide to move forward with a biochar. And I'm sure they'd be happy to entertain any of those questions or options you would have. That would be a council decision though in the long run and a Public Works Committee recommendation. But it is a possibility, definitely. I'll open it up. I know council has been here waiting patiently. Does council have any questions as we wait for maybe a couple questions to be trickled in here?
Doug, I think there's one on air emissions, and I think simply to say that the project is being designed with complete odor control removal that will be in compliance, so there won't be odors from the facility.
We won't have a Yelm aroma, as often called the aroma of Tacoma. So we will not have a Yelm one. You can keep smelling your farms and your local area here. Councilmember Pino, I saw you raise your hand.
Yeah, thank you. I just wanted to, I think it was Doug that pointed out the difference in the type of industry that we have here in Yelm, I guess the lack of. We don't have those dirty industries. So we're not getting any of those chemicals that you would see like in Seattle or Tacoma. Like you said, it's a lot of residential and a very light commercial here. So it's fairly clean water. So I'm looking forward to this project though. It's going to save the city so much money. We're not going to have to ship it out anymore, have it get treated somewhere else and cost us money. It's going to start hopefully making us money in the long run.
There's a question about chemical emissions. Is there any sign of chemical emissions, Valentino, from the biodryer itself?
So my company is really providing the cleaning system for the biodryer in terms of the odor control. So maybe Chris, you want to be covering that?
Sure. Yeah, so through the drying process, as we raise the temp up on the biosolids, there will be hydrogen sulfide, ammonia, amines, mercaptans that release kind of the pungent odor smell. The dryer itself will be under a vacuum, and then all the conveyance equipment that is designed to go to a chemical scrubber that will remove that from the air emissions, and that will be part of the Puget Sound Clean Air or PSCA, right? Puget Sound Clean Air Agency permitting steps that will be part of the requirement. So we will chemically remove that, so the air that's being discharged will not have those chemicals.
Awesome. And then there's a question that I think some of you might be able to answer about other cities closer to Yelm size, the 10,000 to 20,000 range that have biodryers or systems similar.
We do have a biodryer that's coming up, Valentino, correct me, on 3 years of operation.
That's correct, Chris.
And that is in Toppenish, 20 miles south of Yakima. That's at Legends Casino, which is a half MGD MBR plant that was permitted with EPA, and because it's tribal, it was Indian Health Services, not Department of Ecology, but that's been in operation for about 3 years locally. And of course, we have more international and in California too.
Yeah, and the MGD is 1 million gallons a day. So that's about what we're running the same. So you'll see that's very similar to what we run. I like that idea of a day trip.
Yeah, thanks, Paul.
Thank you. Yeah, I would love for council, and I know we have a couple scheduled trips to visit some of these facilities, the Public Works team, but there will be at least a city administrator. I know other people go on there.
The bio dryer is in Toppenish, I believe you said.
Correct. Legends Casino.
I'd answered the last question that just came up.
And here on behalf of the Bioforsec team, we do extend an invitation to all of you if you want to make a trip to the sunny California. More than welcome to come see the installation we have here in the Silicon Valley area. So we do also have the pyrolysis process. So the invitation is open for all of you, of course.
We need to check out some of them in Europe.
Yeah, I think maybe we need to go to Italy.
Yeah, even that, absolutely.
We don't have any other open, well, yes, we do. Rennie, go ahead, Cody, read this one out.
So thank you all. It's been a great presentation. Sounds like a great plan and cost efficient. Keep up the great work. Your answers were quite sufficient for me. Glad we could answer. Again, this was it was driven by council and the mayor, right? The plan, the 2016 sewer treatment plan, the mayor wanting to move forward with the biodryer, and then Public Works Committee vetting this process, bringing it to council and having council approve it. So the thanks goes to council and mayor for allowing this to happen and moving forward and seeing the benefit of building this now instead of waiting another 5 years. So huge thank you to the council and mayor. And that's who the thanks needs to go to for them. So it's been on them.
Cody also deserves a lot of the thanks too for getting this going. He's going to be a little modest about it, but a lot of this was him as well.
Because he knows that we'll step in and say that for him, Joe. No, Cody, this really has been great. I do want to do a couple of clarifying points for the audience. First up, it's Department of Ecology does not require us to have this town hall for this project, but we thought it was really important to show the transparency that we've liked to do the last few years and make sure the public understands what we're up to. Secondly, on the same vein, those of you who know me know my commitment to the environment here locally, and our council has demonstrated year after year after year that we're not going to do anything to harm the environment here that we live and play and work in. So any project that we take on is going to be better for the environment rather than do anything to harm it. So you can, I feel very confident that our continuing councils will support that. As you've seen from previous in the meeting, they do like to follow their comprehensive plan and their water plan and make sure that if they're going to make changes, they do it thoughtfully and with an end goal in mind. Like to thank Parametrics and Force Tech. And I believe Cody backed me up on this, that we will have the question and answer period will be transcribed. This whole program will be linked to our website, as will the project itself. And then announcements of the future town hall meetings, or public hearings rather, will be available on our website and posted on social media.
That is correct. And we'll still be taking questions. So if you have questions, you can still send them over. We'll keep answering them during the process, and we'll have another open public hearing when the plans are 100% complete for feedback. So expect, there might not be another town hall unless we want one or it is desired, but there will be more options to give input. So plenty of time to give input if you have questions or input.
Michelle has been very patient and waiting to answer one last question. If we could address that, please. Do you see it in the question and answer?
Let me see here.
Valentino, she'd like to know the difference between thermal decomposition facilities like in Zurich and this company, your company's bio dryer.
All right. So, Michelle, being 100% honest with you, I am not fully sure what is the thermal decomposition facility you're referring to. I would think it may be a composting facility.
It's an incineration program.
Oh, okay. No, then completely opposite. All right. So incineration it is definitely different than the biodryer. I mean, biodryer is needed to, again, remove water efficiently from organic waste and biosolids. We could compare incineration to pyrolysis as the thermal process, but they are very, very much different. So starting with the first, achievement that our company has gotten here in the US, back in 2015, when we were deploying the first facility, we engaged with the United States EPA, And so we were able to obtain an exemption from being considered an incineration because simply said, pyrolysis has no flame and there's no oxygen. So incineration means that you have an active flame in contact with the material, with the biosolids, with the oxygen, and that causes all of the pollutants, right? Dioxins and all of the other emission concerns that you may have if you have an incinerator next to you. Pyrolysis having no oxygen and no flame directly on the biosolids allowed us to have very clean emissions. That is why we were able to get a permit here in San Francisco, in the Silicon Valley. Otherwise, if I were to deploy an incinerator unit here in San Francisco, they would first tell me you're crazy. Second, we'll never get a permit. And so it's very much different. In terms of energy savings as well, which then leads to, of course, climate change, because the more energy you consume, the more CO2 and greenhouse gas you're emitting. So incinerators also are energy intensive because they are not receiving normally a dry product. They are receiving a much wetter product. So you need a lot of energy to even remove the water and to then burn the biosolids. So very more energy intensive than the pyrolysis process, which is actually self-sustained. Our pyrolysis process does not require any thermal input, but is a self-sustained process. The third aspect to consider, which probably is the more important one, is the byproduct that you will have by doing incineration versus pyrolysis. Incineration, because of, again, the active flame and because of the combustion of the biosolids, will have a byproduct that is called ash. It's just simply ash that has no value and will end up in landfill. So that is 100% waste that sometimes may be considered hazardous because it comes from an incineration process. Pyrolysis will lead you to biochar. So biochar, again, is carbon locked in place for thousands and thousands of years that will never decompose again, that will remain fixed in the product. So biochar has a market value. We're able to monetize on the product sales, not just on the, again, environmental aspect, but as an actual market value. It's a great soil amendment product, as well as we are exploring the use of the product in many different industries, from plastics to make plastics sustainable and replacing a black pigment that is called carbon black. Biochar has the same properties. So we can replace a carbon-driven and emitting source material like carbon black with biochar, even providing more CO2 sequestration. We're using biochar to use as a filter media. We're using biochar to mix with the concrete, to make a carbon negative concrete. There's so many different things we're doing with biochar that is just limitless, honestly. And there's a lot of studies and research out there. We're working with Stanford University. We have, again, waste management on our side, deploying the product together, and a lot of other parties very much active on developing the use of the biochar. So very different concept. Again, the biodryer doesn't really apply here as a direct conversion. Pyrolysis, I may, think as a conversion, but they are very, very different. One is very unsustainable, incineration, and the other one is the future of managing organics and biosolids, finally sustainably. So,
Valentino, maybe to add to that, incineration with biosolids in the United States, there has not been a new permitted facility in the last 20, 25 years. And the 3 incineration facilities in Washington, Bellingham, Edmonds, and Vancouver are all looking at viable options to remove those, because one, they're past useful life expectancy and they're having performance issues in meeting the new constraints and the performance issues with the new standards that are coming out. So as far as incineration with biosolids in the United States, is not viewed by most of the engineering and biosolids world as a viable solution.
Very good. Thank you for curbing your enthusiasm tonight, Valentino.
thank you, Mayor. Thank you so much for having me.
Extremely valuable information that we all appreciate very much. And to Michelle and all the other attendees from Preserve the Commons and others environmentally minded, again, be assured that as new technologies come our way, the city is committed to explore them. Cody and the wastewater facility, Bill Van Buskirk, will always be looking for ways to treat our wastewater stream and be environmentally sound. So with that, I will close the town hall meeting, but I will beg the council to stay on for just a moment. I'm going to make sure that Council Member Stillwell is on, as this is his very last meeting, although we've adjourned that. I do have one very quick thing I'd like to share with Council Member Stillwell. So Hold on just a second.
While he's walking, I'm going to share the BioDryer page really quick so you guys can see. So this is on the city website. You can see the link up here. If you go to Connect, Departments, Public Works, you'll get this list on the side. And you're going to click on BioDryer and Biosolids. And you'll have a quick informational bit about the BioDryer, the company, a couple different pictures along with some frequently asked questions and link to some other information that you might find useful, along with a way to email and contact us if you have more questions. So this is on our city website, so feel free to check this out and it'll be posted again later.
Very cool, Cody. Thank you.
No problem. Thank you guys. Thank Bree for posting this and getting this up.
Very good. All right. Well, before we go tonight, I know that at the last meeting when Council Member Stillwell announced his premature resignation from this body, and we'll tease him about it for a long time. We all remember what a valuable member he's been and will continue to be a valuable member of our community. We look forward to him serving and working with us in so many different ways. As just a little way to say thank you, though, we will be retiring this tonight. And I hope it's all in positive format. You can see that that's his name tag that would normally sit in front of him, and it would have been sitting in front of him again next meeting. But what we've done is we've retired that, and we're giving everybody an opportunity to put a little signature on that and a little sign of our affection towards Councilmember Stillwell, who we will now refer to as just Tad. Council, this will be sitting by the vouchers that you need to sign still and the minutes. So when you come into City Hall, please take a moment to add your name to Councilmember Stillwell's nameplate. And thank you, Tad, again. All right, with that, we are, oh, Councilmember Carmody?
Yeah, I just want to say I'm really sad to see Tad going. I mean, we all started around in 2015, and Tad, you've been a really good, rock steady, sort of middle of the road guy that has helped us figure out our way through over the past couple of years. And I'm so happy to have met you, and I'm proud to have served on council with you. You've been an amazing addition to City Council. Thank you so much for serving, and best wishes in your future.
Thank you, guys. Really quick. I know that I said a little bit last meeting, but I really do appreciate everybody and some of the best advice, and whoever takes my seat and whoever wins the elections. When I first started with all of you, and it's been really kind of a whirlwind, right? 6 years goes by pretty quick, and I cherish those days and want to forget other ones like the rest of us. But if you could pass on, the best advice I got when we first started was just listen and try to understand why people are doing what they're doing or how they're doing it. And if you can just understand that and how we got there, you can figure out how to go forward. That's my, I just want to pass that on. That Tracy Wood actually told me that, and I thought, whatever. And I did. And I learned what I didn't know. And I just really appreciate all the advice and all the friendships we've all worked through and all the challenges. It's really been good. And I've been able to grow personally, and I really, I'm going to miss it. Thanks.
Good idea.
Thanks, Tad. Everybody take a tissue out. We are done. Thank you, staff, for your support tonight. And we will see you all on the 6th.